Hi, students, and welcome to today's lesson. I'm Ms. Albina. Today, we will gather and analyze some fossil data. Are you ready? Grab your pencil and your science journal, and let's get started. Are you ready for another trip back in time? Once again, we're traveling back millions of years. Use your imagination. Where did we land? Oh, we're in a field, and look! I see a butterfly. It's flying around in the warmth of the sun. Maybe it's flitting from one flower to the next. Or maybe it rests on the trunk of a tree. This butterfly is just living its life millions of years ago. Now let's jump forward in time to today. This is all that's left of that butterfly. What do you think happened? We know that this butterfly fossil formed 34 million years ago, which means that this fossil formed after the earliest dinosaurs and before the earliest humans. But I wonder, how did this fossil form in the first place? Do you have any ideas? Did the butterfly get stuck in the rock? Or was the butterfly somehow pushed into the rock? As it turns out, this butterfly fossil is an impression of a butterfly. Have you ever pushed your hand into snow or sand and then noticed the handprint that is left behind? Your hand made an impression. Some fossils form when an organism's body leaves an impression in rock. This impression was left in a rock when dirt and other rocks buried the butterfly. Over millions of years, the matter that made up the butterfly dissolved and left an empty space in the rock, in the shape of the butterfly. Now, this fossil was most likely uncovered by a paleontologist. A paleontologist is a scientist who studies fossils. Have you ever seen a dinosaur fossil in a museum or on television? A paleontologist probably found that fossil. Since fossils can be fragile, paleontologists often take photographs of the fossils they find. That way, they can study the photographs of the fossils and share them with other scientists. And the original fossils stay safe from damage. So, what can we learn by studying fossils? Today, we will think like paleontologists and study butterfly fossils in depth together. But before that, I want to show you something else. Check this out. This is a clay model of a fossil. What differences do you notice between the fossil model and the real butterfly fossil? I noticed that the real butterfly fossil has lines and shapes that are easy to see, but the rock is broken and faded. I also noticed that this fossil model is made of clay, while the real fossil is made of rock. However, I noticed some similarities as well. Both the real fossil and the fossil model have wings and a thin body. Could the same butterfly have formed both this fossil and the fossil model? What do you think? Some of you may already have a quick answer ready, but scientists always have evidence to support their claims. So we are going to look for evidence to help us determine whether or not the same butterfly made both impressions. So, what information can we gather to determine whether the same butterfly formed both the real fossil and the fossil model? Maybe we can observe the shape. Or maybe we can count the number of stripes on the wings and compare them. Oh, I have an idea. Let's measure different parts of the butterflies to see whether the measurements are the same. Scientists often collect data such as measurements to learn more about what they are studying. Let's learn more about our real butterfly fossil and our butterfly fossil model. Paleontologists have already measured this butterfly fossil, and these are the measurements they took. Notice that they took more than one measurement. The paleontologists measured the wingspan, the length and width of the body, the length of two wings, the upper wing and the lower wing, and the width of the upper wing. Having multiple measurements makes it easier to compare this fossil with our clay model. Notice that all the measurements are in centimeters, which is a unit that scientists around the world use to measure length. Let's record the measurements of our real butterfly fossil in this table. As we measure the same parts of our clay fossil model, we will record those measurements as well. Then we can compare the measurements to help determine whether the same butterfly made our real fossil and our fossil model. Let's measure. I'll begin by measuring the wingspan. First, I'll make sure that I'm measuring in centimeters instead of inches. Then I'll line up the 0 on the ruler with the tip of one wing to make sure that my measurement is accurate. I'll measure straight across to the tip of the other wing. Let's see, the wingspan is 5 centimeters long. Now I'll measure the length of the body. Again, I'll line up the 0 on the ruler with the tip of the head to make sure that my measurement is accurate. Then I'll measure straight down to the end of the body. Let's see, the body is 2 centimeters long. And now for the width. I'll line up the 0, and then I'll measure across to the other edge of the body. This one's a little tricky to measure. I see that the edge of the butterfly's body is halfway between 0 and 1, so the body is half a centimeter wide. Now I'll take the rest of the measurements. I'll measure the length of the 2 wings from the top to the bottom and the width of one wing. We have all of our measurement data. I'll record our data in this table. Now we can compare the measurements of the fossil with the measurements of the clay fossil model. What do our measurements tell us? Were the real fossil and the fossil model made by the same butterfly? I see some differences. The length of 2 wings and the width of one wing are different. Let's make some more observations, just to be sure. In addition to taking measurements to study fossils, paleontologists also observe details, such as color and overall shape. Some observations can't be described with numbers, but these details are important to record too. For example, I noticed that the wings on the real fossil have extensions that curl inward at the bottom, while the wings on the fossil model have long extensions on the bottom that curl outward. Can you make any other observations? I noticed that the real butterfly fossil has what look like stripes on its body. It also has wings that extend straight out. I noticed lines coming out of its head, although they are a little hard to see, and I don't see any legs in this fossil. On the other hand, I don't see stripes on the body of the clay fossil model. I do notice wings that extend above the butterfly's head. I also very clearly see 2 long lines coming out of the head, and I can count 6 legs. Let's go back to our table and add these observations to our data so that we have a more complete picture of these 2 fossils. So, what do you think? Did the same butterfly form both the real fossil and the fossil model? If you're thinking yes, why? What evidence do you have? If you say no, why do you think that? What do our measurements tell you? And what do our other observations suggest? So what did we learn from our fossil and our fossil model today? Do you have any ideas about what fossils can teach us about the organisms that made them? Did you learn anything new about our butterfly from its fossil? Your task today is to make a claim about whether the same butterfly formed both the real fossil and the fossil model. Be sure to support your claim with evidence from this lesson. In our next few lessons, we will continue to explore fossils to see what they can teach us about the past.